All right, so we're still in section 3.1D. Continuing with it, we're going to look at fractional exponents when there are variables involved. So I'm going to start by saying let's rewrite these radicals in exponent form. And then we can simplify using our normal rules of exponents. So on number 1 here, I'm going to say that square root is really the same as a 1/2 power. I could write this as 25 xy cubed all to the 1/2 power. Since these are all multiplied, I can apply that exponent to all 3 factors. I'd have 25 to the 1/2, x to the 1/2, y to the 3/2, or 25 to the 1/2 would be 5, x to the 1/2, y to the 3/2. And there is that same square root written in exponent form and simplified. I'll try one more like that. This is a 4th root, so that would be the 1/4 power. Get myself a little space here. So I've got the a squared b c to the 8th, all raised to the 1/4 power. If I once again say, since these are all multiplied, I can apply my exponent to all 3 factors. And when I do this, I'm going to have to multiply the powers. So I'll get a to the 2/4, b to the 1/4, and c to the 8/4. Just multiplying exponents. And I can simplify a couple of those exponents. I can make that a to the 1/2, b to the 1/4, and c to the 2nd. All right, we can also go the other way. If we start with the exponent notation, we can go back and write it in radical form. Here, since the denominator is 5, I know that's really a 5th root on both of them. I'm really thinking of it like this. W to the 2nd, z to the 8th, all raised to the 1/5 power. That denominator of 5, notice, would be applied back in. Now that I have that, I can say, but wait a minute, the 1/5 power is just the 5th root. And I could write it like that. And for right now, we haven't talked any more about simplifying radicals. We're going to leave it just like that. Same idea over here, except because I don't have the same denominator on both of my exponents, right now I can't rewrite it with a single root. So I'm going to fix that. I'm just going to get a common denominator. I'm going to say that's the same as m to the 2/6, n to the 5/6, or m squared n to the 5th, all raised to the 1/6 power. I could rewrite that then as the 6th root of m squared n to the 5th. So the ability to go back and forth between the exponent notation and the radical notation is one that you'll need to have. All right, our last examples with fractional exponents are just simplifying expressions. So all of the rules for simplifying exponential expressions that you already know will still apply. To multiply, we add exponents. To divide, we subtract exponents. And to take a power to a power, we multiply exponents. The only difference is our exponents here will sometimes be fractions. I'm going to encourage you, if fraction arithmetic isn't something you're exceptionally comfortable with, feel free to use the calculator to help you do the actual fraction arithmetic. It doesn't hurt anything, and it will help you get some right answers, hopefully. All right, in number 1, I'm going to start inside my brackets. I know I've got a 1/4 power outside them, but for the moment I'm just going to simplify inside the brackets. This exponent of 2 gets applied to both factors. So I would have 4 squared, or 16, b to the 6th, times b squared, c to the 12th, all to the 1/4 power, which is 16, and I can go ahead and add those exponents to multiply the b's. b to the 8th, c to the 12th, to the 1/4 power. And now I'm going to take that 1/4 power, and I'm going to apply that exponent to all 3 factors. Again, everything's multiplied together, so it's okay to do that. I'll have 16 to the 1/4, b to the 8/4, and c to the 12/4. 16 to the 1/4, or the 4th root of 16, is 2. And then I just simplify my powers. b to the 2nd, c to the 3rd. All right, in number 2, I've got a negative 1/2 power, which I'll apply to those parentheses, and then I've got a 1/4 power, which I'll apply to those. So I have 9 to the negative 1/2, x to the negative 3/2, and then 64 to the 1/4, and x to the 3/4. Both of these factors have negative exponents, so I'm going to move them to the denominator. These two, the 64 to the 1/4, and the x to the 3/4, will stay on top. And then 9 to the 1/2, and x to the 3/2 will go to the bottom. All right, 64 to the 1/4 power. I don't believe that that one actually comes out evenly, so I'm probably just going to go ahead and leave that as the 4th root of 64. Or I could leave it in exponent form, 64 to the 1/4 as well. On the bottom, 9 to the 1/2, the square root of 9 is 3. Now as far as the x, I need to subtract those exponents. And this is what I mean about if you don't want to either take the time to find that common denominator, or if you're just not that comfortable with fractional arithmetic when you're in the middle of a big, long problem, we can use the calculator to help. If I take 3/4 and subtract 3/2, and then just change my answer into a fraction, I get negative 3/4. Now I know that rather than thinking of that as x to the negative 3/4, I'd probably rather put it as x to the 3/4 on the bottom. So that's what I'm going to do. And we'll call that done. All right, last example. On top, I've got a 2/3 power that applies to all 3 factors. So I'll have 1,000 to the 2/3, b to the negative 14/3, and c to the 16/3. On the bottom, the 3/5 again applies to all 3 factors. So I have 32 to the 3/5, b to the 15 times 3 would be 45/5, and c to the 12/5. All right, let's go ahead and see what we can get here. As far as the numbers, this one, well, actually both of them are doable mentally. But again, when they're in the middle of a big problem, there's no real reason not to use the calculator. 1,000 to the 2/3 is 100. Notice that's the cube root of 1,000 is 10, and 10 squared is that 100. 32 to the 3/5 is 8. The 5th root of 32 is 2, and 2 cubed is 8. All right, I only see one negative exponent here, and I am going to go ahead and move that factor down to the bottom. I prefer not to work with negative exponents. So I'm still going to have the c to the 16/3 on top. I'm going to move that b to the 14/3 to the bottom. And I still have b to the 45 divided by 5, that's just 9. And c to the 12/5. All right, we're almost there. 100 over 8. Those are both divisible by 4. So I'm going to change that to 25 over 2. Or again, you could reduce on the calculator like I showed you before if you prefer. B's are both on the bottom. They're multiplied, so I'm going to add the exponents. And here's another good opportunity to let the calculator help us. If I just add 9 plus 14/3, I have 41/3 as the exponent on the b. C's are divided, so I have to subtract those powers. And that gives me 44/15 as my new exponent. Notice that it's positive, so that means the C's end up staying on top. Okay. Not a real pretty answer, but it is the simplified form. And that concludes section 3.1.